Hello, you absolute legends. My name is Eric J. Choi, and I'll be going over Explainer Video 6.1 that shows how a change in temperature will actually change the height of a circular piston on compressed air. And jumping right into the problem. A 50 kilogram circular piston shown in the figure on the right, which is also my diagram for the problem because I don't exactly trust myself to draw something neater than this, and it shows all the relevant information anyways. Floats on 0.12 moles of compressed air. What is the piston height h if the temperature is 30 degrees Celsius? And how far does the piston move if the temperature is increased by 100 degrees Celsius? Now, this problem may seem complicated at first, but it actually gives you every single part that you need in your toolbox of values, that this turns into a simple plug and chug problem right away. So since we're trying to find the height h, we first have to think about what will actually give us a height h with the equations that we know. Now, the ideal gas equation says that PV is equal to nRT. At first glance, if you didn't realize it yet, it's hard to figure out where the h comes from in this equation, unless you remember that V is actually equal to pi r squared h for a cylinder. And that is where the h that we're finally trying to solve for will come from. So, going back to the very top, we need to first find out all the values for that equation. So PV is equal to nRT. We are trying to find V, so we have to find all the other values, such as P, the pressure. So the pressure by the piston is force divided by area. And right here, we know that the force is equal to mg, and the area of a circle is pi r squared, as written right here because of the piston shape. So if we include all of our information, this is the first plug and chug part of the problem, we ultimately get that the pressure by the piston is 62,388.74. Note that this isn't actually the final pressure, and we have to add on the atmospheric pressure onto this pressure by the piston in order to get the final pressure that we need for the equation. So 1 atmosphere converted to pascals to match the pressure we had before is approximately 101,325 pascals. So our final answer for P of the PV equals nRT equation is 163,713.74. Now, as I mentioned before, it actually gave us a lot of information in the description problem. That right there, the 0.12 moles, is automatically the N in the equation. R is the ideal gas constant, which is a given value of 8.314. And the temperature is given in Celsius, and the only thing we need to do to change it into the form that we want in kelvins is add 273 to it. So we actually have all the parts we need, and now we plug and chug to find the volume is equal to 0.00185. And since we're looking for the h value, we plug and chug once again, replacing the volume with pi r squared h, because that is the equation for a cylinder. And we already know the pi r squared from the previous part, so we just get that value again and divide it by our final volume to find the h that we need. Now, the temperature for the system has increased by 100 degrees Celsius. Now, that might seem complicated until you realize it only changes one value in our plug-and-chug equation. So rather than 30 degrees Celsius is 30 degrees Celsius plus 273. So our Kelvin value for temperature in our PV equals nRT equation is 403. Now we do the exact same equation as before, just replacing the T with 403 rather than the 303 we had earlier, until we finally reach a final answer of V is equal to 0.002456, finding the h again using the process we used before for 0.313. And now to just find the change in h values from the temperature change, all we do is find the height final minus the height initial and subtract them like this. And I hope you guys understood it, and not to overcomplicate problems when you first see them. Sometimes they actually give you all the parts in a simple and succinct way but you just have to figure out what exactly they gave you in terms of the problem. Have a nice day, you absolute legends.